Amber! Amber! Oh, my soul. Did I just witness the great Amber step into my life? Is that the case, or is it just me? Or is it just saying Amber is unavailable to co-host? Okay, see. Okay, good evening, everyone. I just need to get a clear thingamabob. Is there anyone that is in need of some sort of like help? You can just let me know in the comment section the grade and what you'd like me to actually help you with. I am here to help. Help. Maybe there's something that's actually on your mind right now that you actually need help with as far as your maths is concerned. I'm here for that. My help is limited though. I'm here to help any grade 8, 9, 10 or 11 learner with anything that they may feel they need help with. So just drop whatever it is that you need help with in the comment section, and I'd be happy to assist if there's anything in particular that you need help with. Okay. Otherwise, maybe someone can also let me know control test wise, when are people starting to write their control test for maths? Any control test for maths happening anytime soon? Any topics that you feel like you're not so good at? Okay. Exponents grade 9, eh? All right. Okay. So let's do PO says exponents grade 9. So let's quickly look at that very quickly. Exponents grade 9. And then slash you saying factorization. Okay, let me just take note. And you're saying specifically difference of two squares, meaning DOTS factorization. Okay. All right. Let us get with the going. So slash. I think let me help PO first, ne? Slash, if you can just hang on or hang tight, I will attend to you just shortly, ne? PO. Let's look at exponents very quickly. For grade 9, these laws are very important. Now, I'm not going to say they are law 1, law 2, law 3, or law 4, anything like that. Just take note, you need to know these laws very well. So the first law, first and foremost, before we even get into laws, this is something you need to note. Okay. A here is something that we call a variable base. M is what we call an exponent, of course. And then 1 is what you would refer to as a numerical coefficient. Okay. So hopefully we can see this. So 1 is a numerical coefficient. In other words, it's a coefficient. A coefficient is a number that stands before or next to a variable. This is a variable and it's a base, all right? Yeah. We also refer sometimes to this as a number base, okay? So basically, a base can take on either a variable, meaning it can be a letter, or a base can be a number, right? And then M is an exponent, right? So e.g., what does an exponent actually tell us? So this base is a numerical base and this 3 is an exponent. So basically this just tells us how many times do I multiply 2 by itself. So 2 to the power 3 means I multiply 2 how many times? 3 3 times, okay? And therefore, if I say 2 to the power 3, that means 2 to the power 3 is 2 times 2 times 2. And hopefully you guys are not saying 2 times 2 times 2 is 2, 4, 6. That's nonsense. It's 2 times 2, which is 4, 4 times 2, which is 8, okay? Guys, I'm just answering someone's question. There's someone who said, and today all I'm doing is just coming on here and I'm addressing any specific things that people have. So Pio said he wants help with exponents, okay? And maybe Pio, as we go along, if there's anything specific that you'd like to actually look at with exponents, then I'll look at that. So let's look at the law. So basically, since we understand this is a base, this is an exponent, all right? And together, we refer to this as a power, okay? So we say, when we read it, a to the power of m, a to the power of m. So this is like 2 to the power of 3. All right, and this simply means that we are multiplying 2 by itself how many times? 3 times, and therefore 2 times 2 times 2 is equal to what? To 8. Okay, Gazi, I will help you out just now. Okay, Slash and Gazi. Okay, you guys said, both of you, factorization. So you specifically said trinomial. Okay, I'll be with you shortly. I just need to help out my good beloved Pio there. Okay, so let's look at the laws very quickly. There's a law that says a to the power m times a to the power n. In other words, if we are multiplying same bases, what we do is we keep the base and we add the exponents. That is one of the laws of the exponents, that if we are multiplying same base, bases, we keep the base, which is a, and we add the exponents. So a typical example is that if we have 2 to the power 3 times 1, and I'm using 2 to the power 3 times 1 deliberately because I want to reveal something else. And 2 to the power 3 times 1, we know is 2 to the power 3, but just bear with me here. 2 to the power 3 is 2 to the power 3. How do we write 1 so that it has the same numerical base as the base 2? 1 can be written as what? 2 to the power 0. Okay, that is 1. 1 can be written as 2 to the power 0, because any base raised to the 0 exponent is equal to 1. Of course, with the exception of 0 as a base, but any other numerical value raised to the power 0 is equal to 1. Especially if it's a positive number, then that base raised to the power 0 is equal to 1. So since the bases are the same, what do we do when we are applying the law of exponents? 2 to the power, we keep the base 2 because it's the same, we add the exponent. So our final answer is 2 to the power 3. And we know that 2 to the power 3 is like saying 2 times 2 times 2, 3 times, which equals to 8. Okay? So remember, guys, this is just a exponential expression, okay? Please take note, okay? So this law says when the bases are the same and we are multiplying, we keep the base and we add the exponents. Law number 2, or one of the other laws, says if we are dividing same bases, all right, dividing same bases. So remember, this line means divide. This same thing could be written in this way, okay? Could be written in this way, a to the power m divided by a to the power n. So what you have here is the same thing as that, okay? So basically, what do we do when we are dividing same bases? We keep the base, we subtract the exponent. So the left hand side subtract the right hand side. If we are dividing like this, the top minus the bottom. So it's a to the power m minus n. Okay, yeah, this is grade 9, guys, because someone asked a specific question about exponents, and so I'm just explaining the laws so that they have a clear understanding first of the laws before they can actually venture into answering any question. So if we have 2 to the power 3 divided by 2 to the power 2, of course the bases are the same. So what are we doing? Since we are dividing same bases, we keep the base, we subtract the exponents. That gives us 2 to the power 1. And obviously 2 to the power 1 can be written as just the number what? 2. Okay, so that is this first law, if you're multiplying same bases, you add the exponents. If you're dividing same bases, we subtract the exponents. So hopefully you guys get the point. Those two laws, they are, they are very important and crucial. Then we have this one. Yeah, I'm going to go into that very quickly. I need to just do the laws quickly so that I can be able to dive into that as well. Okay, so I'm just touching up on the laws. So when a base is raised to a certain exponent, and then outside that particular exponent, it's raised to another exponent, we say that we simply multiply the what? The exponents. When a base is raised to a particular exponent, then external to that particular thing, you have another exponent raised to the entire thing. You simply multiply the exponents whilst keeping that specific base. Okay. So an example would be like saying 2 to the power 3 raised to the power 2. Guys, all we simply do is we multiply the what? The exponents. And then 2 to the power 3 times 2 gives us 2 to the power 6. And obviously 2 to the power 6 is like saying 2 times 2 times 2 6 times, which basically means my beautiful answer is 64. Okay, guys, this is pretty straightforward, the laws, the law. And in conjunction with this law, if ever we have a multiplication of bases inside the bracket, and they are both respectively raised to their exponents, but external to both of them there is a particular exponent. What we then do here, this law is basically borrowing itself from this previous one. All we simply do, guys, is we multiply the exponent p with the respective exponents for each base, because the relationship between a and b is multiply. So this only applies if the relationship is multiply between the bases. And I just want to say the law goes a to the power m times p, b to the power n times p. Do you see that, guys? So I distribute the exponent to the respective exponents for each base, because the relationship that exists is multiply. In the same vein, if the relationship between the bases is divide, okay? If the relationship between the bases is divide and there's an exponent raised on the outside, the relationship between the bases is one of division. They are raised to respective exponents. All we simply do is we distribute the exponent by multiplication to each respective exponent. So we have a to the power m times p over b to the power n times p. So do you see, guys, that this law, it is very much relevant when the bases, the relationship between the bases inside your bracket are multiply, and when the relationship between the different bases within your bracket are divide. Multiply and divide. You can distribute the exponent by multiplication. But please take note, guys. The minute the minute the relationship between the bases is addition, we cannot distribute the exponent p to the respective exponents. The minute the relationship between the bases is subtract, we cannot distribute the exponent p to the respective bases. We only do the multiplication of the exponent for each respective base if the relationship between the bases is multiply or divide. And this is so crucial, guys, because if your maths algebra is to be solid from grade 9 level, please listen to what I'm saying to you, that this here applies only when we are distributing the exponents for bases that are multiplied and when the bases are divided. So base A and base B have a relationship of multiplication. The exponent on the outside can be multiplied to each exponent. A to the power m times p, b to the power n times p. The relationship here between the bases A and B is divide. So we can distribute the exponent p by multiplication to the m and multiplication to the n. That's why we get a to the power m times p over b to the power n times p. But guys, the minute the relationship is one of plus between the bases or minus between the bases, we cannot multiply the p's. You cannot multiply the p's. All right, I'm going to show you here with the numbers so that you can see what I mean. So if we have 2 to the power 3 over 3 to the power 2, and then outside you have raised to the power 2, all this simply means, guys, is that if you are going to apply the exponent externally to each different base, so the relationship between 2 and 3 is one of divide. So now there's an external exponent and each base is raised to each as an exponent itself. So can we apply the exponent by multiplication? Oh, definitely. 2 to the power 3 times 2, bracket removed, over 3 to the power 2 times 2. Do you see that? The 2 got distributed here, the 2 got distributed there. So final answer, 2 to the power 6 over 3 to the power 4. And then final answer, 64 over 81. Okay, hopefully you guys understand that. So this is the relationship between the bases being divided. The exponent can be applied. Let's look at this example. Example 2. 2 to the power 3, a to the power 4, b to the power 2, all raised to the power 2. Now look at this, guys. Look at this. How many bases do you have inside your bracket? How many bases do you guys see? How many? Can you guys tell me the bases that you see? How many bases do you see inside the bracket? Okay, so hopefully you can see that there are 3 bases. Thank you, Koketo. There's 1, 2, 3. There's a numerical base 2, there's a variable base A, and there's a variable base B. What is the relationship between the bases? Okay, the relationship between the bases, what combines these bases is actually multiply. This is 2 to the power 3, it's multiplied to a to the power 4, it's multiplied to b to the power 2. So because of that, I can apply the law that I was just speaking about. The 2 exponent can be distributed to each respective base. 2 to the power 3 times 2, a to the power 4 times 2, b to the power 2 times 2. Do you see how easily and how sweetly I was able to do that? Not even a sweat. 2 to the power 6, a to the power 8, b to the power 4. And then final answer. Do you see? I multiply. 3 times 2 is 6, 4 times 2 is 8, 2 times 2 is 4. Finally, 2 to the power 6 is 64, a to the power 8, b to the power 4. Inside, phakathi, guys. Isn't that just sweetly done and neatly beautiful? Because the relationship between the bases is one of multiplication. That's why the exponent can be distributed by multiplication. Brackets mean multiply for the exponents. So they can be distributed by multiplication to each base because the relationship is multiply. Here, the relationship was divide. So therefore, remember guys, 2 to the power 6. What is 2 to the power 6? It's simply 2 times 2 times 2. How many times? 2 times 2 times 2 times 2 times 2 times 2. Okay? That is basically how I got the answer. Alright? It's just that I know this off by heart, new page. That's why I could just write the answer. Okay? Remember that this is a base raised to the exponent 6. So what does it mean? It simply means 2 multiplied by itself 6 times. Please be able to read this. 2 multiplied by itself how many times? 6 times. All right. So with the use of the calculator, you can simply get the answer without having to really think about it if you don't know it off by heart. But it's just that someone like me who's been doing this now for quite some time is pretty much well acquainted. So that's how you got the 64. I hope that makes sense to you. So that then again, here the relationship was one of divide. Okay. And since the exponent on the outside is 2, I can distribute by multiplication so that I can get the answer. But remember what I said. Please note the following. Can you do this when there's addition? Can you do this when there's addition between the bases? Guys, please take note. 2 to the power 3 plus 2 to the power 4 raised to the power 2. Remo says never. And guys, I want you to remember, you can never, ever do it. It's never everable. Right? We don't do it. Okay? And maybe if I can do it with smaller numbers, you guys will appreciate why we say we cannot do it. Please take note, guys. 2 to the power, I'm just gonna do plus here. Let's say that I forgot, and what I do is 2 to the power 2 times 2 plus 2 to the power 1 times 2. It's because, you know, I'm the way that I am. I forget the laws. So I go ahead, I distribute the exponent by multiplication, but there's addition in the mix. And then let's just say I go ahead, 2 to the power 4 plus 2 to the power 2. Okay. And then final answer, we get 16 plus 4. And I'm like, yeah, I've got this. So I say, you know, in my head, I've got this. Final answer, 20. Now, let's be practical, guys. Let's be practical. Okay? This is nonsense, right? All of it. All of this that I've done here is nonsense, and it's nonsense squared. Okay? It's nonsense squared. We said that when there's a plus and a minus sign between the bases, we do not distribute the exponent. Okay? And maybe some of you will appreciate if I simply do this quickly so that you can see that indeed, man, it can't be the case. What's 2 to the power 4? Okay? 2 to the power 4 is equal to what? It's equal to 4, guys. Okay? 2 to the power 4 is equal to what? To 4. Because remember, 2 to the power 2 is simply saying 2 times 2. We are multiplying 2 by itself, right? So we get 4. What's 2 to the power 1? What's 2 to the power 1, guys? Just tell me, what's 2 to the power 1? Anati Tafini, thank you for answering the first question. What's 2 to the power 2? You are 100% correct. Thank you, Smil. So 2 to the power 1 is 2. Thank you very much. What is 4 plus 2, guys? Okay, so that we can appreciate what's happening. 4 plus 2 is equal to what? Because 4 and 2, they are like terms, so we can actually add them. What's 4 plus 2? Thank you, Lord. It's 6. And then, what is 6 squared, guys? What is 6 squared? Once we add it, what's 6 squared? Okay. Remember, 6 squared simply means 6 times 6. Thank you, Remo. Thank you, Loa. Thank you, Leah. Paul. Thank you, Medo. Thank you, Yaya. Pio. 6 to the power 2 is not 12. Guys, let's be careful. Remember, what did I say? The exponent simply tells us how many times we need to multiply a particular number that's given by itself. So 6 squared, if we apply now the square, it's simply like saying, we know 6 is raised to the power 1. So it's like saying 1 times 2 in the exponent. 6 to the power 2, guys, is simply what? 6 times another 6, which is equal to what? To 36. Can you see the difference between this answer, 20, and this true answer, 36? Do you guys understand why now I'm saying to you, when there's addition between the bases, we do not apply the exponent by multiplication to each base? Why? Because between the bases, if it's this addition, we don't do it. Okay? Yeah, I'm glad you do understand, Kinati. I'm glad you do understand. Makes sense, ne? Okay, now that it makes sense, I hope you will appreciate why I said to you guys that if the relationship between the bases is divide, then it's fine. It's fine. Look at that. You can apply the exponent to each respective what? Base by multiplication. Okay. Yes. Sihlem Charlie, I like what you have said. Could we have expanded and have two brackets? Definitely. It's just that would have basically just made our life, a bit longer, but we would have eventually arrived at the answer. But the minute you realize that, we can, 2 to the power 2 is 4, 2 to the power 1 is 2. The addition of these numbers can be done. It's 6. What's 6 squared after that? It's 36. It's much more shorter. So we just need to have a comprehension of what the situation is like when we are doing something, okay? So that we don't spend our time doing, like I said, this nonsense. This, guys, is absolute nonsense. And I repeat, nonsense. So when there's a plus sign, we do not distribute the exponent. I hope you guys get my point now very loud and clear. Okay? We do it, though, the distribution, when there is a division relationship between the bases, and when there is a multiplication relationship between the bases, then this exponent just comes inside and is distributed by multiplication to each exponent so that we can get our simplification done. Okay? So I hope we get that law. Straight up, have left hook and sinker. Okay? This here, we don't distribute by the exponent, whether there's a relationship of plus and whether there is a relationship of what? Of minus. Whether the relationship is of plus and minus, we do not ever distribute the exponent. We don't do that, guys. We do not do it at all. So I hope you guys now get the point very loud and clear. Okay? So now I'm sure now you can appreciate the law that the relationship a to the power m times b to the power n, we distribute the exponent by multiplication to each respective base if the relationship is one of multiplication between the bases, and if it's a relationship of division between the bases that are different, then we can multiply the outside exponent to each respective exponent for each base. But with plus and minus, we cannot. No, it's a no-go zone. It's a no-go zone. It's a no-no. It's a no. All right. Okay, let's move on. After that law, I'm sure you guys can see now. Let's look at this. A to the power 0. What's a to the power 0 equal to? Pio, I hope you are still here, Pio. A to the power 0, guys, is equal to what? Any base raised, or at least let me say the base a raised to the power 0 is equal to what? Yes, you guys are right. It is 1. And please take note, guys. Please take note of that. Now let's look at a few examples, because now I love what happens when I look at a few examples. 2 to the power 0. Let's go, guys. What's 2 to the power 0? Come on, type for me. Yeah, Bano, yeah, Inez, Peo, Kim, Sobele, everybody, contagious. So contagious. What grade is this? It's grade 9. Okay, yes, 2 to the power 0 is equal to 1. Okay, let's look at another example. That's example 1. Let's look at 2. Negative 2 to the power 0. Caught you. I caught some of you. Listen, guys, please take note. Listen. You can stop typing now. I saw your varied answers. Some of you are saying 1, some of you are saying negative 1. Check this out. So 2 to the power 0 is equal to 1. Very important. Question. This 2, is it positive or negative? Was it positive or negative, this 2? Okay. This 2 is a positive 2, right? But it is raised to the power 0. But the answer remains positive. Remember, the 2 is raised to the power 0. Okay? So 2 to the power 0 is 1. But what was the sign of this particular expression? It was positive, so the answer is positive 1. Please take note, guys, here. Negative 2 to the power 0. The 2 is raised to the power 0. So it is equal to what? To 1. But is the 0 exponent affecting the sign? No, it isn't. So therefore our answer is what? Negative 1. The answer, guys, is negative 1, not positive 1. Okay, so we must be very cognizant of what we have as our sign and check is whether the 0 above the number including its sign. So in this case, we have negative 2 to the power 0. The 0 applies to the numerical value, but not to the what? The negative sign. So the answer is negative 1. Please take note of that. If you grasp this, guys, you will be a happy guy, happy man. Negative 2 to the power 0. Let's ask this one. What about this one, guys? What's the answer? Negative 2 in brackets raised to the power 0. What is the answer, guys? Negative 2 all raised to the power 0. Okay, this time round, negative 2 all raised to the power 0 is actually equal to positive 1. I will explain why we say so. Guys, hey, there are things you need to be aware of when it comes to exponents. First and foremost, someone tell me something. 0. Is 0 an even number or is it an odd number? Let's start there. Is 0 an even number or an odd number? User says it's odd. Guys, Remo says it's both. All right. Okay. Please listen to me and listen to me very well. For the exponent's sake, we assign 0 as a even number. Hey, what? We assign 0 as an even number. For the exponent's sake, we assign 0 as an even number. Now, this 0, which is an even number, please go and do your research. Some of you, I know, you're probably thinking, this guy, he is speaking nonsense. Please go to, you can go to any search engine and go ask the question, 0, is it an even or odd number? Have fun, guys. You will be shocked what you learn. Some of you, I think you do maths and you do it for the sake of doing it. You know, when you understand things a bit deeper, you're like, what in the world? Now listen to me, guys, very quickly. The entire number is raised to the power 0 this time round. It's not like this situation where the 0 was just above the 2 and not the negative sign included. Here in this case, the 0 is raised to the whole thing, including the sign that is negative. So when we look at this even exponent, we look at applying it not only to the number 2, but to its sign that is what? That is negative. Now, you need to ask yourself this question. Let me repeat what I just said. When you have the 0 exponent and the bracket is there, it means we apply the 0 exponent to the sign of the number as well. So we apply it to the sign and to its number. There's this thing SN, L, the 3 letters usually see when you are about to watch a movie that you shouldn't be watching. In mathematics, guys, SNL simply stands for not what you think in the movie. It's sign, number, letter. So when you look at this exponent, 0, and the bracket which is encompassing everything, this 0 exponent must be applied to the sign and it must be applied to the number. So listen to me then. Since 0 is an even number, even numbers do something magical to the signs. 0 exponents or even numbers in this situation, because 0 is an exponent is an even number, they do something magical to negative signs. Exponents that are even. What do they do, guys, to negative signs? Even exponents do what to negative signs? If those signs are within the bracket where those exponents are raised, what happens to the negative sign if an even exponent is applied to it? Yes, user, they make them positive. They make them positive. Okay, so this 0 has influence over the negative sign because 0 is watching over everyone. I usually say exponents are like surveillance cameras. They watch over everyone inside the house. Okay, so basically the minus sign is affected. It becomes positive. The 2 is raised to the power 0. It becomes 1. So that's why the answer is positive 1. Sign gets affected. Number gets affected. If there was a letter, it would also get affected. But we don't have any variable basis here. Look at this situation, the previous one. Does 0 affect the sign? No, it doesn't. Because 0 is simply raised to the 2. But the sign is left unaffected. That's why the answer is what? Negative 1. Guys, I hope you understand this. Who is with me here? Do you guys feel me, what I'm saying here? Hey. An even exponent, guys, an even exponent will affect a negative sign inside the bracket by making it positive. So I love what someone said here. It will make it positive. Okay? No. System Charlie. There is one exception. This a to the power 0 is equal to 1 is only true if a is not 0. The thing is 0 to the power 0 is actually undefined. It's the only exception. 0 to the power 0 is undefined. You go to your calculator, it will say maths error. That maths error means it's undefined. So that's the only exception. But all the other natural numbers, they are raised to the power 0. They are going to be 1. Okay? So hopefully you understand that and that makes a lot of sense to you. Okay? Light bulb moment. Yes, please. The light bulb moments are very important. Very, very crucial. So please, guys, let's take note of these exponential things. They make the difference. Once you understand, if there's a bracket, everyone inside the house is affected. The exponent will affect everyone. Okay? So let's look at one last example, maybe just one last example, so that we can okay. Okay, look at this one. Negative 3b to the power 0. Who is affected by the 0 exponent? Is the sign affected? Is the numerical value affected? Is b affected? Who is affected by the 0 exponent? Sitlem Charlie, you are 100% on point. The 0 exponent affects b. So basically, what we are then saying is, this negative is not affected. It will stay like that. The 3 is not affected. It will stay like that. The b is affected. We change it to 1. And the reason is, we change it to 1. And the reason why I'm putting brackets is because brackets mean what? Multiply. You can put a multiplication sign if you want. You can put a dot to signify that it's multiplication. Because remember, guys, there are 3 significant. We can always do this when we are saying multiply. 3.1, this dot means multiply. The brackets, parenthesis brackets mean multiply. And then obviously the sum symbol or the sign means multiply. And you'll find that brackets seem to or tend to be more famous because, they're in case. So now negative 3 times 1, the final answer there is negative 3. So that is my answer. Okay, do you see this, guys? Do you see how sweet and simple and straight to the point this thing is? It's like, there's nothing to it. It's a nice it all comes together, if you know what I mean. So hopefully this 0 exponent is very much appreciated. Okay, and please remember, we always talk about the answer being 1. Okay, negative 3 is not affected by the 0. The 0 exponent only affects in this situation the value of b. So that's why it changes to 1. But as for the minus and the 3, they remain as negative 3. And remember that the relationship between negative, the 3, and the b is one of multiplication. Multiplication combines things. That's why negative 3b to the power 0 is written or read as such, because multiplication combines numerical coefficients, variables, and so forth. It combines those together. Number 5. I'm just going to do one last thing. Look at this, guys. If you were to be given a problem like this and they say to you, simplify 5x to the power 0 plus 5x, okay, all raised to the power 0. Question is, if you simplify this thing, how do you go about it? So 5 is not affected by this exponent. So 5 stays, x to the power 0 becomes 1. Do you see that? You would have to show this, guys, so that whoever's marking you can award you the marks. What you don't want to do is to just write the answer. You need to show the steps where it shows that you understand and comprehend what you are doing. So Remo, I like what Remo has done. If you look at Remo's comment section, very astute and straight to the point. The 5 and the x are both raised to the power 0. You apply the 0 exponent to everything, it becomes 1, because everything in the bracket is basically 1. Right? If you were someone that was petty, maybe you would even take it like this and say 5 to the power 0. You distribute the exponent 0 to 5, and then you say x to the power 0 as well. But at the end of the day, this is 1 times 1, which still gives you 1. So, I mean, you have the law, this definition, to sort of back you up, because everything in the bracket is raised to the power 0. Okay, does that make sense? So like I said again, 5, is it affected by the power 0? No. So 5 stays the same. Is x affected to the power 0? Yes. So therefore it becomes 1. Plus 5x, the entire thing is raised to the power 0. Is it affected by the 0? Is everything inside the bracket affected? Yes. Everyone in the household is affected. So it becomes 1. Then board mass or bad mass, better yet. You know, when we're dealing with exponents, we start talking about bad mass. Brackets, exponents, division, multiplication, addition, and subtraction. So obviously, you would never say 1 plus 1 and say it's 2 and then say 2 times 5 is 10. That would be absolutely out of the realm of bad mass. Okay, so we apply bad mass. That leaves us with 5 times 1, which is 5. Multiplication is done. Now addition can follow. Multiplication is done. Addition can follow. 5 plus 1 is equal to 6. Okay, guys, I hope you guys are sweet and sound and you can see this thing. There's nothing much to it. The last thing I want to do for you grade 9s when it comes to these exponents is to now look at negative exponents. And I want you to look at these with me very well. Okay, negative exponents. Okay, you can ask Sihle, what do you want to ask Mr. Mchali? Okay, I'm going to look at negative exponents just very quickly. Okay, and I need to then turn my attention away from this because there was someone else that had asked a question, and today all I'm doing, guys, I'm just hopping on here to answer any questions that people do have. Okay, yeah, so negative exponents very quickly. I don't, is it IDK what to tell you? IDK what to tell you. Something you need to note is that exponents for grade 9 and exponents for grade 10 are pretty much the same. Simplification of exponents for grade 9 and 10 are the same. Solving for x for grade 9 and 10 is the same to a certain extent. We add a few things in grade 10 for the grade 10s when it comes to exponential equations. Otherwise, the simplification is pretty much the same. Okay, yeah. Now, before, okay, I write this thing. Guys, listen to me, those who are joining in. When I came into this live, I did not come here to teach a specific thing. I just came on and I asked someone a question. What are you guys struggling with? So someone indicated that someone in grade 9 sent me a comment and said, grade 9 exponents, sir, can you explain grade 9 exponents? So I was like, okay, no, it's fine. I'll explain then the exponents and do the laws, in the process. So whilst I was doing that, this has basically become a lesson. Not that I had come here to do exponents. I just was like, guys, anything that is you're struggling with, okay? And I want to move away from this after this, because I'm going to just do negative exponents very quickly. Then I'm going to slide away from negative exponents and go and answer a question that someone else had asked about factorization in grade 10. I think it was Slash and Ghazi. I don't know if Slash and Ghazi are still here. Slash and Ghazi, if you guys are still here, please let me know in the comment section so I can know that, okay, you are still here, and then I can address your thing after this. So a to the power negative 1, guys, base raised to a negative exponent. Yes, I do. Of course I do. And maybe I can do a few exponential equations for you so that you can sort of have an idea what the exponential equations are about. Because I just want to cover the laws first, okay? For those who are just joining in, okay, I basically have been looking at exponents, all right, the laws of exponents. So I first looked at the base raised to the exponent. We looked at law 1, how when we multiply same bases, we keep the base, we add the exponents. Law 2, how when we are dividing same bases, we keep the base, we subtract the exponents. Law 3, when an exponent is raised to a particular exponent raised to another one, you simply multiply the exponents. And how then this law can be extended, that if you have different bases that are multiplied and they are different inside the brackets, all you do, if there's an exponent on the outside, you apply what you said here, which is you multiply each exponential, each exponent with its respective base with what's outside, and you do the same with division. When there's division of different bases, you do the same. You multiply the exponents for the numerator and the denominator. But we do not do that with addition and subtraction of bases inside the bracket. It is a no-go zone. We do not multiply. All right. Then of course I looked at some examples to sort of like verify what I was saying. And then we looked at the zero exponent, the application of the zero exponent, how it goes about. And then now I'm just smack bang here at the negative exponent. And this is like my long way of answering Pewo's question. Like I said, there was a guy called Upewo who asked exponents in grade 9. I'm not really gung-ho what's happening there. Okay, listen up now. This a to the power negative 1. What did you guys say? What is the answer? A to the power negative 1 is equal to, I think someone actually did comment in the comment section. Pain Hub said the answer is 1 over a. Now, how is that so? Is the question that people are asking, and they are probably asking, why is that so? Okay, maybe in the same vein, let me ask this question. What is a to the power negative 2? If you guys are saying a to the power negative 1 is equal to 1 over a, what's a to the power negative 2? I'm going to wait for you to answer in the comment section. And then I want to explain something so that maybe you can appreciate. You see, the answers are revealing to me the misconceptions. The answers are revealing to me that there are misconceptions. Okay? They are revealing to me that there are misconceptions. Okay, do you see, guys? What if Snay answered it very well? 1 over a squared. 1 over a to the power of 2. 1 over a squared. Okay? Any other answer, guys, is incorrect. So the answer is 1 over a squared. Now, what is happening here? This is what's happening. When a base is raised to a negative exponent. This is what I want to explain. When a base is raised to a negative exponent, when a base is raised to a negative exponent, the base changes position and the exponent changes. I repeat. So let's repeat this, guys. What is this thing saying? When a base is raised to a negative exponent, the base changes position and the exponent changes. Okay? When a base is raised to a negative exponent, the base changes position and the exponent changes sign. Or the exponent sign changes, if you want us to put it that way. When a base is raised to a negative exponent, the base changes position and the exponent's sign changes, if you want to put it that way, or the exponent changes sign. Okay, well, I think the exponent sign changes. Maths teachers were never English teachers, but that has to change, if you know what I mean. The English needs to English. When a base is raised to a negative exponent, yes, the base changes position. So the base changes position and the exponent sign changes. Now I want to show you something. Okay, maybe by doing this you guys will appreciate the answer, and maybe, just maybe, who knows, by appreciating the answer you'll then be able to appreciate what happened. Okay, so guys, please take note what's happening here. I want you to tell me, all right, initially, if you have a to the power negative 2, what don't you see that is actually there? There's a lot of things that I hear that we don't see, but we need to reveal them because we cannot see those things. So I want to reveal the things that we do not see, guys. Yes, there is firstly a coefficient of 1. Okay, so this is it's not just a to the power negative 2. There's a 1 before the a. It's invisible, very true. Invisible 1. And then below the a to the power negative 2, there's another 1, guys. And this is what I want to share with you. Maybe you guys, for the longest time, were not appreciating what is not seen. And I want to reveal what is not seen. Finally, imagine they say the grand reveal, and then all of a sudden they reveal that all this time around us, before us, behind us, below us, we are just surrounded by a multitude of angels, and they are there, and you survived that car accident that you once were in a few years ago, and you're like, man, look at me, like, how amazing am I? But the thing is, there are things that are around you, below you, above you. so yeah, man, let's come back. So there's this 1 that we cannot see. So what did I say in that statement that helps us understand what happened as we write the answer? So in other words, we said when a base is raised to a negative exponent, what happens? The variable base does what? It changes position. It was in the numerator. Now it is in the denominator. Changes position. Then the exponent changes. So from negative 2, the exponent becomes positive 2. Now, as a to the power negative 2 leaves, who does he leave behind to man the situation in the numerator? What was the numerical coefficient? It was 1. So 1 is left behind. So a to the power negative 2 leaves the numerator, goes to the denominator, positions himself next to this denominator, which is 1, which you cannot see. And then its exponent sign does what? It changes from negative to what? To positive. Okay? So that's why we say a to the power negative 2 is equal to 1 over a squared. It has everything to do with that. So I hope you guys can appreciate that a lot. Look at this. 3a to the power negative 3. 3a to the power negative 3. The negative exponent is raised from the a base. Is the 3 affected by the negative exponent? No. So what do? The 3 is stationed in the numerator because it's not affected. The a changes position from numerator to denominator, and then its exponent changes from negative to positive. Therefore, the answer is 3a to the power 3. Guys, are you seeing this? Hey, I hope you are seeing this, guys. I hope you are seeing this. So in the same vein, guys, if we have 3 over a to the power negative 2, very, very important. Very, very important. A is raised to the power negative 2. What happens? The base changes what? Position. It leaves the denominator, it goes to the numerator, joins the 3, is multiplied to the 3, gets raised to a positive exponent. Who gets left behind in the denominator? 1. But then obviously that 1 in the denominator does not hold significant value for the value of 3a squared. So therefore we can write 3a squared as just 3a squared, instead of writing the final answer is 3a squared over 1. Just want to do one more, guys, so that you guys can really take this away. Okay, 3 over 2a to the power negative 4. The exponent a is raised to the power, the variable base is raised to the power negative 4. Is 2 affected by the exponent negative 4? No, it's untouched. Okay, so how do we write the answer? The answer will be equal to 3 remains in the numerator. The 2 also remains in its denominator. The a, since it's raised to the power negative 4, changes position from the denominator to the numerator, and then its exponent changes from negative to positive. 2 is a number of significance, so therefore the answer is 3a to the power 4 over 2. Okay? Look at this one. 3 over 2a all raised to the power negative 3. What about this one, guys? So there are 2 bases inside the bracket. They are raised to the power negative 3. So what do? First things first, the 3 is in the numerator. It stays there. The 2a, all of it is raised to the power negative 3. So what I do is I'm going to change its position. When it changes position, it will have a relationship in the numerator of multiplication with 2a to the power positive 3. Who gets left behind in the numerator? 1. Do you see this, guys? All of 2a went to the numerator because it's all raised to the power negative 3. but then its exponent changes from negative to positive. Then finally, we are not done. This 2a to the power 3, please let's remember we can go ahead and simplify, but we need to make sure when we do so, we remember BEDMAS. Brackets, exponents, division, multiplication, addition, and subtraction, because we have varying operations. You can't take this 3 and multiply with the 2, but you need to first apply the exponent 3 to 2 and a. So the 3 is there. We apply the exponent 2 to the power 1 times 3, a to the power 1 times 3. I'm doing this so that you guys can appreciate the fact that the exponent 2, the variable 2, the base 2 has an exponent 1, the base a has an exponent 1. Then I have 3 into 2 to the power 3, a to the power 3, which I can then finally say 3 into, what's 2 to the power 3? 8, a to the power 3. Okay, remember, 2 to the power 3 means 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. And then now I can take the 3 and multiply with 8a to the power 3. And all I do is I multiply the numerical values. 3 times 8 is 24, a to the power 3. So this answer resonates with what my good friend typed in the comment section. Unkanyezi Bengu. Very good, young man. Very, very good. Okay. Right. Do we now appreciate this thing of negative exponents, guys? And the simplification will be spot on as long as we can do the application of the negative exponents. No problems. Okay. All right. So for my grade 9s, just before I turn over my attention to the grade 10s with the trinomial and the factorization and the difference of two squares and maybe even the fraction equations, I just want to look at this rule which helps us with exponential equations. And the rule that helps us with exponential equations for grade 9 simply says if a to the power x is equal to a to the power y, then x is equal to y. Okay, this helps us with exponential equations. Yeah, I'm glad you are happy. If you are happy, I am happy. Yeah. But no, I'm happy too. A to the power x is equal to a to the power y, then x is equal to y. In other words, if you have same bases, single bases on either side of the equal sign, all that we are told here is that if you want to solve for x or you want to solve for an unknown, you simply drop the base, meaning you drop a, and then you equate the exponents. But the bases must be the same in order for you to go ahead and solve for the what? The unknown in your exponent. Okay. IDK what to tell you. Okay. Same bases for grade 9. They always make it a point that you are able to convert those bases to be the same. For grade 9, you will never get a situation where the bases are not the same and converting them to be the same is not possible. For grade 9, it will always be a case where you can have the bases being the same. If you are in grade 10 and they do that, then it simply means that you need to use the trial and error method. Okay, IDK what to tell you, please send me a private message. You can send it there on TikTok, all right, so that I can share with you maybe some other way that you can use on the side to be able to easily get the answer if ever the bases are not the same. They shouldn't be testing you. At least they shouldn't be putting you under that sort of duress, but if they do, then I guess there is a way, all right, but it's just that it's an unconventional way that in grade 10, all right, which the way that's easier if you don't use trial and error method, because there's a trial and error method that you're supposed to utilize in grade 10. But that trial and error method, it can also munch up your time. It can take very long, so it's always nice to have this other side method that I would recommend that you utilize. So just contact me on the side. So for the grade 9s, like I said, exponential equations, this is your law. So in other words, if you look at an example very quickly, let's say 2 to the power x is equal to 2. And they're like, solve for x. Okay. 2 to the power x is equal to 2. So what you can see here is that the bases they are the same. They are what? They are the same, guys. So if the bases are the same, all I do is I do what? I drop the base and I equate the exponents. But now we need to make sure we know what the exponent is here. Okay, it's the unseen one, the invisible one. So we drop the bases, we equate the exponents. So x is equal to what? To 1. Because the variable, the bases, the numerical bases are the same. So you can go ahead now and apply this rule, okay, because the bases are the same. Let's look at another example very quickly. 2 to the power x is equal to 4. So here, initially you look at this and you're like, the bases are not the same. What am I to do? No. All right. And please, let's not make the misconception of basically wanting to divide both sides by 2. Remember, this is not a variable base this is not a base that is a variable, this unknown. It is an exponent. So therefore, we need to look at this particular approach. If a to the power x is equal to a to the power y, in other words, if the bases are the same on either side, we can then drop these two and we can equate x and y to get x is equal to y. Gamo, you are spot on. Gamo in the comment section says change 4 to the power 2, 2 to the power 2. Very good, Gamo. Okay, very good. All right. And if you remember, okay, 4 can be written as 2 to the power 2. Okay, and if ever you are at loss as to how to convert, this is a composite base. In grade 8, you guys did composite numbers, remember? We convert composite numbers to prime numbers. In other words, we use prime factorization. And when we don't know how to do it, our calculator, the scientific one, you can always take the number, press equal in grade 9, press shift and press fact, and then you will get the answer, which is 2 to the power 2. So you can never be at loss as to how to write down, a composite base number to a prime base. So 4 is a composite number, okay? Numbers that have more than 2 factors, but 2, which is a prime number, is a prime base. It's written as 2 to the power 2. That's how we get what? That's how we get the base that is applicable. So since the bases are the same, all we do is we drop the base and we equate the exponent. So our answer will be x is equal to what? To 2. Okay. Oh man, let's look at another one. 2 to the power x is equal to 1. Maybe you guys are gonna think that 2 is always the 1. Let's look at this one. 3 to the power x is equal to 1. Okay, this is for grade 9, guys. I'm doing this for grade 9. This is an answer to Pewo's question. Pewo had asked a question about exponents, so I'm just trying to address some of the sort of like the things that have to do with exponents where that is concerned. So 3 to the power x is equal to 1, but obviously this also applies to grade 10. It applies to grade 11 to some degree. Yes, Kamo is like spot on there. We changed 1 to 3 to the power 0. Very good, Kamo. Very, very good. Then, because 1 can be written as a base raised to the power 0. So if we want to align the base that we need to change to, we look at the base that's already there. Because once the bases are the same, we drop the base, we equate the exponent. The answer is x is equal to 0. Okay, right. And guys, obviously there's more and stuff like that. But we'll hold it right there for tonight. Okay, so Pewo, please in the comment section, can you let me know if there's a level of satisfaction? Obviously, I know you're probably like sitting there and you're thinking to yourself, well, there's so much more questions that are specific that I would have wanted to ask. But you know what, Pewo? What's important here is to know the basics. At least you need to know the laws, the definitions, so that when you know the laws and the definitions, you can then be able to answer questions related to exponents. One other thing I want us to look at very quickly is this situation. fraction raised to a negative exponent. So when a fraction is raised to a negative exponent, all we do is we simply swap. We change a to become b, we change b to become a, and then our negative exponent will change to positive. That's it. That's it. So in other words, if you have 2 to the power over 3 raised to the power negative 2, you can change that to 3 over 2 raised to the power positive 2, and then all you do is you apply the multiplication of that exponent, and all you get is 3 to the power 2 over 2 to the power 2, which is 9 over 4. So in other words, a fraction with a negative exponent, all you do, guys, is you change the denominator and the numerator so that it changes the sign of the exponent externally. All right, and that's how you basically are able to change negative exponents to positive exponents. The thing is, there's a rule that says our answers typically in any simplification of exponents must be left with a positive exponent. So this obsession of basically making sure that we know the negative exponent is all about ensuring that our answers, when we are simplifying, are never left with a negative exponent being there. So since we know that any base raised to a negative exponent simply means we change the position of that particular base, and then we change the exponent from its negative to positive, that helps us to be able to facilitate being able to write an answer that has a positive exponent. So hopefully that also clears up why this obsession of making sure that we know how to convert negative exponents to positive exponents. And they insist in these questions that you will usually be given that write your answer as a positive exponent. Okay. All right, I think that wraps up that exponential fiasco that we are having. Hopefully that was a fun exponential fiasco for people that were here. Now, very quickly, I just wanted to check if these following individuals, I know I've kind of come around, like Uslash and Ugazi asked me to do factorization. So I'm just going to look at that. Factorization is really important, okay? Very, very important. Okay, I'm going to look at factorization. I'm just going to do a quick sort of like session with that. You're welcome, Peo. Peo, you're very welcome. Hopefully it helps you a lot, and that moving forward you can kind of have a bit more ease, all right, especially as you're observing me do the work. At the end of the day, you need to give yourself a chance and do the work yourself so that you can begin to see that, oh, okay, these laws are starting to make sense. But not only that, for me, applying the laws is coming nicely, you know, and so forth. Look at Ukamo. Ukamo is like, when will you be doing analytical geometry? Are you kidding me, guys? Like, are you guys for real? Like, I mean, really now? Really, Kamo? Guys, this is like this is like a freestyle session, because I see people are like here, they're like, when will I do this topic? When I do this topic? Okay, at the beginning of the session, as I was explaining to many people that have come in so far, I just came in and I was like, guys, I'm here to answer any questions that people may have. So Slash earlier on said, can you do factorization? And by that, difference of two squares. Okay, so what I'm gonna do is I'm gonna do that. Sure, Kamo, that's a compliment and a half, and I appreciate that compliment. Okay, so very quickly, I'll do Kamo in the future your analytical geometry. It's just that I didn't anticipate that people would be saying that they are doing analytical geometry. Okay, wait, what? James, x squared minus 9, guys, difference of two squares. Okay, yes, Kamo, we open two brackets. Okay, but we open two brackets after doing a few things. All right, I usually do a check before we even do anything. Okay, if you are looking at this and it's factorization that you have to do, the first thing I usually ask for any type of factorization is I usually say, you need to ask yourself this question first: how many terms do you have in the expression? You must start there. How many terms in the expression? Okay, now I hope you guys know that what separates terms in an expression is a plus and a minus sign. So if you check this out, there's a minus sign, which definitely then means there are how many terms? There are 2 terms. Thank you very much. 2. The first question you need to ask yourself, is the expression in the right order? Yeah, we'll do that khabane because I'm busy with factorization. So I'm going to do difference of 2 squares, do trinomial, and then definitely try and fit in some cubic as well. So after you ask how many terms there are, you need to ask yourself, is the expression in the right order? And by that, guys, I simply mean, if you're looking at the expression, this expression is called a quadratic expression. All right, I know that this is called a quadratic expression because its variable has the exponent 2. That means quadratic. Okay, there are also linear expressions because linear simply means that its exponent has the exponent 1. The variable will have the exponent 1. So this is a linear expression. This is a quadratic expression because its x variable has the exponent 2 and it's followed by a constant term. All right, so is it in the right order? Yes, it is. X squared first followed by a constant. Usually a trinomial has the x squared term followed by the x term followed by the constant term. So please guys, just internalize this with me. You ask yourself how many terms there are, then 2. You check, is the expression in the right order? And this here is in the right order because it being a quadratic expression, the standard form of a quadratic expression is when you have your x squared term first, followed by your x term, followed by your constant term. Then after you have verified all of that, you can then ask the next question. Is there a highest common factor? And by that, you look at the sign. You look at the number, you look at the letter, you look at the highest common factor sign. Guys, if the sign for that first term is negative, you must take it out. If the sign for that first term is negative, you take it out because you automatically take out the sign if the first term is positive. Without even thinking about it, you actually take out the sign if the first term is positive. So even if the sign for the first term is negative, you must take out that negative sign as a highest common factor. So when I say take out, like, is there a highest common factor, you must look at it in 3 things. You must look at it, is there a highest common factor sign? Is there a highest common factor number? Is there a highest common factor letter or variable? Please guys, please, SNL, not what you see on TV guys, but sign, number, letter, sign, number, letter. You take out those, you see. So these questions are important. How many terms? 1, 2. Is the expression in the right order? If it's not, please make it to be in the right order and don't change anything. So for instance, it's like if this question I was given to this question like this, you know what I would do? I would ask how many terms there are, and then I'd be like, there's 2. Then second question, is the expression in the right order? And the thing is, it's not. So my x squared term is positive, followed by my constant term, which is negative. So therefore, this is the expression in the right order. This is my expression, my quadratic expression in the right order. So I hope you guys are understanding why I insist on this thing of please ask yourself how many terms. 2, is the expression in the right order? 3, is there a highest common factor? Sign, number, letter. If the first term is negative, you take out that negative sign as a what? As a highest common factor. Sign, number, letter. Please people, please. All right, and then let's go. Okay, so how many terms are there here? There are 2 terms. Is the expression in the right order? Yes, it already is. Next question. Is there a highest common factor sign, number, letter? Well, you know what? There's a highest common factor sign. It's positive. But that positive sign will not affect this expression if I take it out. Number. Is there a highest common factor number? Guys, there is a highest common factor number. Can someone tell me what the highest common factor number is between x squared and negative 9? Anyone? What's the highest common factor number? Okay. No, it's not 3, guys. The highest common factor number between the coefficient 1 and the constant term 9. Thank you, Lesego. We have you, Nkanyezi, Lesego, and Lwandle. They basically answered correctly. The highest common factor number between, you see, this x squared has a coefficient that is 1. So you're looking at this term and this term, and you're asking yourself, what is the highest common factor? Remember, guys, what is the highest common factor by definition? A highest common factor is that number. It is the factor, it's the highest factor, okay, between 1 and 9. It's the highest common factor between 1 and 9, okay. That particular number will go into 1, it will also go into 9. That's what a highest common factor is. It goes into those numbers without leaving a remainder, but it is the highest number that can go into 1 and 9 without leaving a remainder. So that highest common factor number is 1. All right, and I know we don't really think about the fact that it's 1, but please take note of something here. So after answering that question of highest common factor S and L, then the question then is, what type of factorization additionally can we apply to what we are looking at? So then we can see this is a difference, because difference means minus. X squared is a perfect square. 9 is a perfect square. Okay, perfect square numbers. Okay, if you take the square root of any perfect square number, you will actually get a number which, if you multiply by itself, will give you back that particular number or that particular term. So 9 is a perfect square because 9 is made of 3 times 3. X squared is a perfect square because if you take x and you multiply it by x, you get x squared. Are you with me? All right. So what we do, because we know this is difference of 2 squares, first things first, we take the first term, we take the square root of the first term. What's the square root of x squared, guys? It is, I'm not going to write the answer. What's the square root of x squared? Thank you, Koket. So it's x. Thank you so much. What is the square root of 9? Because if it's a perfect square, guys, if we apply the square root, we should get whole numbers, or in this case a single variable. Yes, Lesego, it's 3. Thank you guys, you're amazing. So that means we write x here and x there. Why? Because x times x will give me back the x squared. We write 3 there, we write 3 there. Where did I get the x from? I took the square root of x squared, I got x. Where did I get the 3 from? I took the square root of 9, my second perfect square, and I got 3. That's where they come from. So I have 3 and 3. Then minus. The minus sign for the difference suggests that I will have in the bracket different signs. The minus sign for my constant always suggests that I will have different signs inside the bracket. Does it matter if I start with plus and end with minus, or start with minus and end with plus? It doesn't matter. But I suggest, guys, since you know that the minus will suggest that there are different signs, since the negative sign suggests that there are different signs inside your bracket, please start with the positive sign and end with the negative sign. Just do that as a matter of tradition. I will tell you why in the next problem. Prof, you will understand why in the next problem. So look at this. This is x plus 3 into x minus 3. And this is how we factorize the difference of two perfect squares. Hey bo, is this Yele? Oh my goodness, Yele. I watch you a lot, my friend. Good seeing you. X plus 3 into x minus 3, that's how we factorize. Does anyone have any questions here? Any questions at all? Okay. And do you remember when I said to you guys, we take out a highest common factor, sign, and a number? All right. Look, outside this bracket, who is there that we don't see? Can someone tell me? You open two brackets, but without realizing it, you took out something without even realizing it. Who is available? Yes, Kamo, yes, Koketo, yes. Outside the bracket, there is a 1, and he is positive. He's outside, but we cannot see him. Hey, yo. Guys, I don't know what more you want me to say. I feel like I've preached an entire sermon, but people don't even see that I've preached an entire sermon. Say that the angels will be around you, before you, above you, below you, and I don't know what more people want. Okay, let's do this one. Look at this. 3x squared minus 75. Okay. Now, if you go back to my questions that I said we need to always ask ourselves when we're doing these questions, then you'll be like, you'll appreciate this step-by-step process that I keep on going through. Yeah, you see, that's the thing. No number must be left behind. Very true. Now, if you look at x plus 3 and x minus 3, can you factorize any further? No, we stop dead there. We can't go on any further. So let's come here, guys. Here's another question. First question, how many terms? There are 2 terms. First question, answered. Second question, is the expression in the right order? 3x squared minus 75. Is the expression in the right order? I'd say yes. 3. Is there a highest common factor? Because if there is, if we have a sign, a number, and a letter, we take all of those out. What is that highest common factor then? Do we have a highest common factor sign? Obviously, definitely, we always do. Do we have a highest common factor number? It seems like between 3 and 75, there is a highest common factor number. Is there a highest common factor letter? Doesn't seem like there's a common factor letter. So look at this. Positive 3, as you guys have said, is a highest common factor. Okay? Is a highest common factor. Now, what is left inside? X squared, because 3 times x squared gives us back the 3x squared. Then lastly, minus, because positive times what gives you a negative? It has to be a negative. And then we have negative what? 3 times what gives me 75? It's 25. Thank you so much, guys. Yes. So inside my bracket, I have x squared minus 25. I have just completed highest common factor, sign, number. There was no letter, so there was SN that I had to take out, the sign that was positive, the number that was positive. And remember, what you write inside, 3 times what gives you 3x squared? It's x squared. 3 times what gives you 75? It's negative 25. You can always do this as well. What's 75 divided by 3? Then you'll get 25. Are you with me? Now, inside the bracket, it seems like I'm not done with this factorization. There's one last step. Then when you do that last step, don't forget the 3. It was there. It does not all of a sudden disappear. X squared minus 25. There are 2 terms. They are in the right order. What is the highest common factor? It's already out. So now we need to factorize. What type of factorization is this? What type of factorization? What kind of expression do we have here? No, it's not difference of 2 cubes, but it is difference of x squared is a perfect square, 25 is a perfect square. So this is a situation of difference of two squares. So what do? We open two beautiful what? Brackets. Powell. Okay, we open two beautiful brackets. Two beautiful brackets. Then we do what after that? The square root of x squared, it's x. The square root of 25 is 5. Alright? And then, what do we do there? We put plus and minus because our sign is taken care of, no problem. Okay? We don't want to stress about signs because negative for our constant simply means that signs are going to be different. Negative constant means different signs. So we start with positive, we end with negative. Then this is x, this is x, this is 5, this is 5. Can we factorize any further? No, sir. So therefore our answer is this. We look at this bracket, we can't factorize any further. We look at this bracket, we cannot factorize any further. So therefore that is our answer. Okay. Who would have thought? Who would have thought? Okay. That's what I call 2-in-1. Highest common factor, dots. 2-in-1 factorization. Okay, let's look at another one. Let's look at another one. Okay. Now when people look at this, they're like, and then, what is this? What is this? Dots means difference of two squares. Difference of two squares. Difference minus of two perfect squares. X squared is a perfect square. For a grade 10 learner, you must remember that. 25 is a perfect square. For a grade 10 learner, we must remember that. So what we do, whenever we have a difference of two squares, we open two brackets. We take out the square root of x squared, we get x and x, because x times x gives us x squared. Square root of 25 is 5 and 5, because 5 times 5 is 25. And then because there's a difference, that means different signs inside your bracket. So there's a plus and a minus sign. Okay. Okay. All right. I hope that settles that. Okay. Sorry guys. I just want to change it up here. I want to change up the question. X to the power 4 minus y to the power 4. Okay. Yeah, it's definitely chai. It's chai, dear. Okay. All right, guys, remember this is factorization of an expression. Okay, factorization of an expression. I'm not dealing with solving an equation here. I'm dealing with how to factorize an expression. And there's a difference between an expression and an equation. This is an expression. So x to the power 4 minus y to the power 4. Okay, hopefully you guys can appreciate this. So what is this situation that we are seeing here? So first and foremost, how many terms? There are 2 terms. Secondly, is the order fine? Yes, the order is fine because we have x to the power 4 and we have y to the power 4. They basically have the same exponential sort of like take. All right. Then 2, is there a highest common factor? Yes, definitely there is. The highest common factor. There is a highest common factor sign, which is positive. Is there highest common factor number? Yes, it is. There's a 1. Okay, that is a highest common factor number because there's a coefficient of 1. There's a coefficient of 1 here. That's negative. So the highest common factor number and sign is positive 1. Then lastly, is there highest common factor letter? Not really. Okay, not really, because this is x, this is y. So before we even start, the next question then is, since 1, when we take it out, is not really significant, what type of factorization do we have here? So that's where we jump into this and we say this is a 1 difference, okay, of what? Of 2 2 squares. Now you're gonna say, how so? Okay, x to the power 4, guys, is a perfect square. Y to the power 4 as well is a perfect square. And I want to suggest that any base raised to an even exponent is a perfect square. Any base raised to an even exponent, because 4 is an even exponent, is a what? Is a perfect square. So that's why I can confidently say this is a difference of x to the power 4 is a perfect square, y to the power 4 is a perfect square. Why? Because x to the power 4, this 4 is an exponent that is even. This 4 is an exponent that is even. Therefore, these are 2 perfect squares. So this is a difference of 2 squares. So if that's the case, what does that mean? It means I need to open 2 brackets. Do you see, guys? So I hope you can see it means I can open 2 brackets. And when I do, right, I'm going to say what is the square root of x to the power 4. Okay. And remember, guys, if you remember in grade 8, whenever you apply the square root and you want to remove the square root, it's like you are dividing the exponent that is there by what? By 2, which therefore means when you remove the square root, it becomes x to the power 2. What about y to the power 4? It's y to the power 4 over 2, which is y to the power 2. Do you see that, guys? Okay, so therefore that means I have x squared, y squared, plus minus. So someone like Ghost was spot on in their answer. Ghost and my good friend, who seems to be such a genius, Unkanyezi Bengu. Okay, right? Then you would think we are done, but you look again in the brackets and you're like, ish, this first bracket cannot be factorized any further because it's not a difference, it's a sum of 2 squares. But a sum of 2 squares cannot be factorized any further. So the x squared plus y squared is fine. The second bracket, x squared minus y squared, can be factorized. All right, because this here is still a what, grade 10s? What is this still regarded as? Okay, Zol Cage, you are 100% spot on. There is still a difference of 2 squares in this bracket. So we first retain this bracket, which has x squared plus y squared, because we won't do anything further. We cannot factorize any further. Then what we do is we open 2 additional brackets for this last bracket. And maybe some of you will be like, oh, that's why sir insisted that we put a negative sign for our last bracket. That's in the case where factorization can still be done. You guys see why I insist that we start with positive for our first bracket and then we end with negative in our last bracket. The whole point of doing that is so that we can accommodate the difference of 2 squares for our last bracket if it is still possible to factorize further. Okay, so what does that mean? Square root of x squared, this time we can flow nicely, x and x. The sign, plus and minus. Square root of y squared, y and y. Done, dusted, in the bag. Man, I factorize like a pro. You're probably saying that inside of you because you are a pro, man. Look at you. You are factorizing like a pro. Like you are killing it. Difference of 2 squares is nothing, right? Okay, please guys, please. Okay, Okay. Okay. 36x squared minus 9y squared. Maybe you can do that on your own. Just do that for me quickly, and then in the comment section you can comment with your answer. 36x squared minus 9y squared. Let me give myself a breather and allow you to do that one, and maybe this last one as well, and then we'll do a correction of it after you're done. Come on, I'm sure you've got a pen and a paper out there. You're doing your things, or you can just type it in the comment section. That would be appreciated as well. So number 2 firstly you can do, and then you can do this one as well. Factorize. Okay, all of this is saying factorize. Tell me about it. From exponents to factorization. Are you kidding me? Then I'll transition and I'll do trinomials after this, so that you guys can at least get a taste of what factorizing a trinomial looks like. Okay, so you guys can do these 2 and 3, and do them for me, and then in the comment section you can grace my comment section with your comment of answer, and I'll be happy to see your comment of answer. Yeah, has been here for a while. Hey, you talk about someone who is hanging on for dear life. He's been doing the most. Lesego, Ghost, Uyanda, Gazi. Gazi has been here. My goodness, Gazi, you were actually the one that asked for factorization of trinomials. I'll be definitely doing that after these 2 examples. I've got you, buddy. Swoosh, Maro, Ria, Kalipa, Pixelated. Lwandle, you here as well? Lwandle. Aista, Child of God, Sabrina, Yonelisa, Bullet, Mabuto, Tando Lwetu, Ma'am, Shimza, Kusto, Miss Kip, DJ Lupa, Mhlobiso, Mpo, Global Security. Oh, my sis. I hope you're well, sis. I hope you're enjoying varsity, eh? I know you've been living your best life there, university vibes, and I see you're also pushing content there in the channel, and also on TikTok and your lives. I see those. Matola, Ndwentle Lesedi, Mike Lolo, Styles, DK, Katlego, Bloom, Lindiwe, Nolwetu, Estrim, Bimbi, It's Kutlwano, Lilita Boy, Ntlanhla, Wethu, Monica, Jamie, Hlamulo, Fifi Zilo. Hey guys, hey. All right, is it coming out, guys? Are you getting it? 3x squared minus 9y squared, the factorization of that. Is it happening? Is it happening? Is it for hey pen? This is 36. This is x squared. This is 9y squared. Alright. So I'm sure you guys asked yourselves the initial questions that I said you should ask. 1, how many terms? There are 2 terms, guys. Definitely 2 terms. Second question, after asking how many terms there are, you ask yourself, is the expression in the right order? Well, it is. Okay, it is. Because these are both square terms, right? There's x squared, there's y squared, there's 36 followed by 9, that's fine. Third question, is there highest common factor between 36 and 9? You guys see a common factor between 36 and 9? Highest common factor between 36 and 9. Yeah, hopefully you guys can see highest common factor between 36 and 9. It's like in your face, eh? Because if there is a highest common factor, you first take that out, which is very important. Taking that out is very key. Alright. Taking that out is very key. And then you get left with what you get left with, and then you roll with what's in the brackets. Okay? So that highest common factor that everybody is saying it is 9. Definitely, thank you. 9 is the highest common factor. Okay, 9 is the highest common factor. Thank you so much for seeing that. Between 36 and 9, 9 is the highest common factor. So when you factorize, guys, the steps are so crucial, okay? Because this thing of asking is the highest common factor is sort of like the foundation of how you start with your factorization. With any type of factorization, you may see trinomial, you can see difference of two squares, but before you even jump into that other type, first ask, is there highest common factor? Then take that out. Now, if you take out the 9, what are you left with inside? 4x squared minus what? Minus 1. Do you see that, guys? How beautiful. Then I can get that mark. I can be awarded that mark for taking out the highest common factor. Okay? Then we are not finished. Inside the brackets, there's further factorization that can be done. Okay? So it's like that 2-in-1 factorization. So what do? We open two beautiful brackets there. Then what do we say? We ask ourselves, what's the square root of 4x squared? Because it's a perfect square. Square root of 4x squared is 2x. Okay, so that means we have 2x and 2x. You see that? Then the square root of 1. What's the square root of 1? It is 1. So then you have 1 and 1. Then since it's difference, it means you first put plus followed by minus. I love the fact that I forgot the y squared. Did you see that, guys? I forgot the y squared. I took out, thank you so much. I love how Ganyezi sort of like saw that and he actually typed that in the comment section. Okay, so yes, it was supposed to be 9 into 4x squared minus, you have 1y squared. Yes, we were supposed to have started off like that. Okay, yeah, because remember there's the y squared. So let's not omit the variable. If it's there, we take out the 9, we're left with 4x squared, because 9 times 4x squared gives us back the 36x squared, and 9 times 1y squared gives us back the 9y squared. And we took out the highest common factor, the biggest factor between 36 and 9, which is 9, which is very good. Then after that, we open two brackets, we factorize. So we take the square root of 4x squared, which gives us 2x and 2x. Take the square root of y squared, we get y and y. Remember, the square root of 1 is 1. Okay, so we have 1y. But even if we don't put the 1 before the y, it's there. We know that the 1 is there. Then we say plus and we say minus. Sorry, let me just put plus and we put minus. Do we factorize any further? Nope. Okay, where does the 4 come from? Remember, we took out a highest common factor of what? Of 9. So 9 times what gives us back the 36? 9 times 4. Okay, so that's where the 4 comes from. Or you can simply say 36 divided by your highest common factor, which is 9. It will give you the 4, because you need to figure out 9 times what gives you back the 36x squared. So it's 4x squared. That is your first term inside the bracket. Then you ask yourself, 9 times what gives you 9? So it has to be 9 times the 1. But then the y squared also needs to feature. Alright, not like what I did initially where I did not feature the y squared and I made a grave error. Okay, so please learn from my errors so that you don't have to repeat them. Okay, always be vigilant, always be aware, always take into consideration what you have written down so that you don't ever make silly mistakes along the way. Does that make sense? Okay, and then you'll be fine. Okay, and guys, this one, okay, before I jump into trinomials, because I do want to jump into trinomials, but what I will probably do is I will end the live after this, because I don't want to have a very long recording. I upload these for people to go and watch on my YouTube channel, which is basically the link on my bio. I do want people to be able to have the liberty of doing that, so I'm going to end the live and just restart it so that I can restart trinomials alone. And and then cover those for the benefit of those that are here. Okay. No problem. I'm correcting mistakes, that's fine. May you please explain something similar to this? Similar to this. Okay, so ma'am, is it ma'am? Is it ma'am or is it ma'am or ma'am? So 36x squared minus 9y squared, so if you look at this, I said that whenever we approach factorization of trinomial, we need to ask the questions: how many terms? There are 2. Is this in the right order? Yes, it is. Then 3, is there a highest common factor between these 2 terms? Because asking is there a highest common factor will help you be able to take out the highest common factor. And I said when you take out the highest common factor, you take out the highest common factor sign, the highest common factor number, the highest common factor letter, if there are any available. So in this case, 36 and 9, all right, the number that goes into 36 and 9, the highest number that goes into 36 and 9 is 9. Okay, 9 goes into 36 4 times, and then 9 goes into 9 once. Okay, so that's why we take out a highest common factor of what? Of 9. So we write that outside as 9. Okay, then letter, there's no highest common factor letter. The sign is positive, so there's a highest common factor sign and number, which is positive 9. Then you want to check what's left now after you've taken out the 9. So what you would then do to find out what's left inside, there are 2 things you can do. You can either ask yourself, what is 9 times what gives you back the 36? Okay, and then you can say 9 times 4. Or alternatively, if you want to find what this number is, you can say 36 divided by 9 using your calculator. 36 divided by 9, you will get 4, guys. You will get 4. Okay. Bullet, how do you know that the number is the highest common factor? It goes back to what you learned in grade 8. How did you find the highest common factor between 2 numbers? You see, now you are taking me back and you are taking yourself back. Now, guys, I'm not gonna lie to you. When people ask me these sorts of questions, okay, and I want you to receive this in the heart that it is meant to be received with. I am saying this not to make you feel small or anything like that. What I'm realizing is that the more I teach people, I know other teachers as well will agree, it almost feels like sometimes learners don't really take seriously what it is we are teaching. And if they do, they don't take to heart what they are being taught. Okay, so for instance, I know for a fact that in grade 7 and in grade 8, you guys learned how to find a highest common factor between 2 numbers, right? And there were methods that you learned on how to find the highest common factor. Okay, and by now at this stage, you should be able to clearly distinguish or know the highest common factor between 2 numbers. So for instance, 36 and 9, how do I know that it is 9, that 9 is the highest common factor? All right, so you either used a method like this in earlier grades where you wrote out all the numbers that go into 36. In other words, all the factors of 36. You would list them. All right, you would list them, or you would use the ladder method to find the factors, the highest common factor between 36 and 9. All in all, whatever method you used, it helped you to be able to get the highest common factor. So I want the person who asked the question, maybe a bullet, if you are a learner that is in grade 9, this term already you learned, if you're in grade 10 actually, you learned how to find the highest common factor in earlier grades. So you need to go and recap the method of how to find the highest common factor, because moving forward, we need to have fluency in being able to find the highest common factor between 2 numbers. without even thinking too much, you see. So yeah, that's my pain for teaching, because sometimes I feel people don't take too hard, and it does lead to a bit of frustration when people do that, okay? Because this is like prior knowledge you should have as you are now in this grade, and the ease in doing what you are doing now will depend on how fluent you are in doing other things that were done in earlier grades, right? So for those learners that are probably not in grade 10 yet and are still coming up, please make sure that you take very seriously what you guys are doing in grade 9, so that when you come up to grade 10, 11 and 12, you do not find yourself in a place where you cannot do certain things that were done in earlier grades, and therefore they impact you negatively when you are doing other procedures that have to do with other content that you do in later grades. So 9 times 4x squared will give you back the 36x squared, but it is the highest common factor that we need to take out, not any other factor. For instance, between 36 and 9, there's other factors that are common, like O3, but that's not the number that's the highest. We want the number that's the greatest, that is common between 36 and 9, and that's what we take out, because that's what will ensure that what we write inside the bracket has been simplified, is as simplified as possible. If we do not take out the highest common factor, what we will find is that what is inside the bracket can still be simplified by taking out another highest common factor, which is what we are trying to avoid. We want to avoid having to take out another highest common factor and then having to take out another highest common factor again. We have to take out the highest common factor the first time round, so that it puts us in a place of simplicity where we can factorize further if possible. So now that we have 4x squared minus y squared, this is a difference of two perfect squares. We open two brackets, like I said. Difference of two squares by nature means when you have a difference of two perfect squares where there's no highest common factor to be taken out anymore, what you then do is you take the square root of that particular first term, which in this case 4x squared is 2x, okay, the square root of 4x squared, and then square root of y squared, which is y, and then you plus, you put minus, and that pretty much completes our factorization. Okay, x minus 4, the whole thing squared, minus 36 is another problem, that is also a type of difference of two squares, and I want us to look at it because it's a type of difference of two squares, and maybe people may not notice that it is, okay, but it actually is a difference of two squares, because this here, if I ask how many terms are in the expression, okay, do we know how many terms are in this particular expression? How many terms there are there? Let's see. Let's see what the commentary has to say. Okay, people are saying 2, 2, 2, 2, 2, 2. And I'm very happy that you guys are saying 2, because this here is one full term separated by a minus sign, and this is another single term. So in total, we have 1, 2. If you are here and you said 3, then it is because you were probably thinking of this like this. You are saying this is one term separated by a minus sign, this is the second term, and then you're saying this is the third term. But the thing is, you are wrong in your thinking. Why? Because again, in grade 9, you see guys, these things, in grade 10, you get affected by grade 9. You don't know things in grade 9, you get affected negatively in grade 10, and then grade 10 becomes a pain. Things become a pain in the grade that you are in because you did not master and then carry forward your mastery into the next grade. That's the problem. That's where the danger is. So grade 9, you guys learned, you would get asked questions. How many terms? If I write A, how many terms are there? That's 1. How many terms are there? If I write B squared, how many terms is this? This is 1 term. Then you guys learned this. A bracket makes something become 1. Once you put brackets around, it doesn't matter that inside you have 1, 2. The minute you put brackets around, that becomes one term. This is actually a single term the minute you put brackets around. Okay? Yeah, this is very important what I'm saying here. Okay? And then A over B. A fraction as well is one term. Okay? Okay. This person, Mr. Imbongi, grade 12, I do in the week at 5:30 in the morning. Okay. So this weekend, I will not be able to do any grade 12 work, but in the week, every morning, and this coming Monday, I'll be continuing on with inverse functions. So, yeah. All the work that I've done so far is on my YouTube channel. You're more than welcome to go to my bio, go to my link, go and press on the link that is Maths is a Game 5 to 7. It's the YouTube channel. I've uploaded all the sessions that I've done. So basically all the sessions I've done on sequence and series. I recently started with inverse functions. So I'll be continuing on with inverse functions. I did, for grade 12 inverse functions, I did how to write the equation of an inverse of a function, and then I did another second session which was how to draw an inverse function with its original function on the same set of axes, and then how to determine the domain and the range. So I'll be continuing on from there on Monday. Okay, so I do grade 12 5:30 in the morning weekly, every day, because that's the only time I can actually really avail myself for that. Okay, my time is really sorry, because I'm busy. I'm a busy guy. I'm a busy teacher. Anyways, A over 3, guys, sorry for that. A over B is also one term. Okay, because a fraction is referred to as being one term. You can even have something like this. This is all one term because it's a fraction. Okay, so a fraction is one term. So all of this is one term because it's a bracket, one term. Okay, so please understand that. So that's why we say how many terms are in this expression. There is 1, there is 2. Okay, please understand this. When you understand it well, you are fine. Okay, so that's why I go through this question. How many terms are there? There are 2. Is this in the right order? Yes, it is. All right. This is the square minus a constant. Okay. So basically, this is one term squared and then minus a constant term. So, do we have a highest common factor? Okay. Now, this bracket has a coefficient of 1. And then this is negative 36. So if you were to say, is the highest common factor? Yes, it is. It is positive 1. But obviously that 1 is not of significance. But what we see next is that we have a difference. 36 is a perfect square. X minus 4 squared. This bracket is a binomial squared. So we have a difference of 2 squares. This is a binomial squared. So what I'm going to do is I'm going to open 2, and I call them square brackets. And why am I opening 2 square brackets? I'm opening 2 square brackets because for my first bracket, I need to take the square root of x minus 4. Okay, which would basically mean this is x minus 4, 2 over 2 if I remove the square root, because I divide this exponent by 2, which basically gives me x minus 4 to the power 1. And that one I don't have to really represent. So that means in my first term inside this square bracket, I'll have x minus 4, and I will also have x minus 4 on the other side. Okay, I want you to tell me in the comment section if you get me. If you do, say yes. If you don't, say no. Do you understand what I've just done? Okay, let's say it says yes with like a slithery snake, yes. Ghost says yes as well with a single letter S. Luanda says yes with a triple S. Okay, it's giving snake vibes as well. Ndosh as well. Ndosh has a nice profile picture, eh? Nice profile picture, Ndosh. Ghost has a scary profile picture, my goodness. Like a skeleton that's like walking the Walking Dead, that type stuff. Yeah. And Lwandle just looks like such a professional person on his profile picture. It's like he took a professional picture. Okay, it seems like there's no nose. Okay, then the second term, what is it? The square root of 36, which is 6. So I place 6 and 6. Are we together, guys? All right. Then, since it's a negative sign for the constant or the second term, then I put plus, I put minus. Okay. Now I'm sure you guys can see that this is x minus 4 plus 6. This is x minus 4 minus 6. Then my small bracket, because they are potential like terms, the minus 4 and the plus 6, I am going to, because I've put a bracket, there's a 1 here which I cannot see. I distribute it, I remove the bracket, I guess x minus 4 plus 6. Then my square bracket can become a nicer bracket like this, because I just did a square bracket so that I can differentiate between the bracket for x minus 4 and the bracket for the entire expression inside the bracket. Same thing in the other side. This is x minus 4 minus 6, and then I can add the like terms inside the bracket. So this becomes final answer x. What's minus 4 plus 6? Positive 2. Then minus 4 minus 6, negative 10. So this is how I factorize this difference of two squares, with a bit of sassiness, in that it is a binomial squared that is basically comprising my difference of two squares. Okay, a bit out of the sort of like ordinary, but at the end of the day, it is a conventional question which can potentially be asked. Okay, right, and I hope you guys are vigilant and are mindful of that particular question. So what I wanted to do, guys, now is to actually end this live. I'll restart it just shortly so that I can just finish off trinomial, so that I can just do trinomial very quickly, and then yeah, I'll call it a night. I think you grade 10s have basically got the last bit of my time, and then yeah, I'll call it a night. Let me just end this live. I hope you guys don't mind too much. I need to, so that I can actually